In the previous video, we have created an object, an instance of the class by using the new operator. Now the question is, can we create more than one objects, more than one instances of a class? What will happen if we create an object without storing its reference in the stack? What will happen if an object loses its reference, that is connection with the stack frame in the program? In this video, I will answer these questions. Namaste everyone, I am Gyan and you are watching the session 5 of Java and Web, user-defined data type. In this video, we will learn about the more than one instances of a class and garbage objects. You can see here we are creating more than one objects using new operator. And from previous video, we know that whenever we create an object of a class, then the bytecode of that class and other class level data gets loaded into the method area. But if you create more than one objects of a given class, then the class level data and the corresponding bytecode gets loaded into the method area only once. So even if you create more than one objects of a given class, the loading of the bytecode and other class level data of that class occurs only once, that is for the first time. Let's see this code by animation. In this code, here we are creating two objects of the class add and storing references of those classes in the reference variables a1 and a2. In these two lines, we are printing the instance variables corresponding to the objects referenced by the reference variables a1 and a2. Then after, we are changing the instance variables I and f corresponding to the object which is referenced by the reference variable a1. And again, we are printing the instance variables I and j corresponding to the objects which are referenced by the variables a1 and a2. Let's see the execution of this code by using animation. We need to execute bytecode corresponding to the class main. We cannot execute the bytecode corresponding to the class add because class add does not have a public static void main string array args. So the execution starts from the class main and the JVM memory gets created having method area, heap and stack. The bytecode of the class main gets loaded into the method area. So the method area contains bytecode and other class level data of the class main. Then after, JVM calls the main method of the class main and a stack frame of the method main gets created into the stack section of the JVM memory. The location for the variable args of type string array gets located into the stack area of the method main. Then after, we have next statement to execute add a1 is equal to new add. We already know that from our previous video that this statement creates a new object of the class add. Whenever we execute this line, the bytecode of the class add gets loaded into the method area. And now method area contains the bytecode and other class level data of the class add. And at the same time, the location for the variable a1 gets created into the stack frame of the method main, which contains an address. And this address contains object of the class add. The object of the class add contains the instance variables inside it, which has values 2 and 4.7. Then after, we need to execute other statement add a2 is equal to new add. This line creates a new object of the class add, but at this time, the bytecode and other class level data of the class add will not be loaded into the method area. Location for the variable a2 gets created into the stack frame of the method main, which contains address of the created object. The newly created object is stored at the address addr2, which contains instance variables of the class add I and f with the given values. We already told that addresses in the memory does not look like addr1 or addr2. It looks something different. We are using notations like addr1 and addr2 for the convention. In the next line, we need to print the instance variables I and f corresponding to the object whose reference is stored into the reference variable a1. The address, the reference stored into the reference variable a1 is addr1. So it prints the instance variables I and f corresponding to the object stored at the address addr1. And it prints a1.i is equal to 2 and a1.f is equal to 4.7. Then after, we need to print values of the instance variables I and f corresponding to an object whose reference is stored into the reference variable a2. The reference variable a2 contains address of this object. So it prints a2.i is equal to 2 and a2.f is equal to 4.7. Now can we change the values of instance variables of a given object? The answer is yes. By writing a1.i is equal to 5, you actually change the instance variable I of an object whose address is stored into the reference variable a1. Since the reference variable a1 contains the address addr1, where the object stored is this one. That's how the value of the instance variable I of this object gets changed to 5 from 2 after execution of this statement. Then after, we are changing the instance variable f of an object whose reference is stored into the reference variable a1. Since the reference variable a1 contains the address of this object, So the new value of the instance variable f of this object is 3.2. Finally, again we are printing the instance variables I and j corresponding to the object stored into the reference variable a1, which prints a1.i is equal to 5 and a1.f is equal to 3.2. It prints the new value. In the next line, we are printing the instance variables I and f corresponding to the object whose reference is stored into the reference variable a2. Since the reference variable a2 contains the address of this object, so it prints a2.i is equal to 2 and a2.f is equal to 4.7. So after the method main completes its execution, then the stack frame of the method main will be erased. And after the bytecode of the class main finishes its execution, then the execution of JVM will come to an end and all JVM memory will be erased. Let me try to execute this code in a Java program. Open kelsey.java and this is the code. This is the same code as we seen. Let me save and compile it. Java C kelsey.java. Compiles fine, then run it. Java main, because the class name containing the method main is main. Press enter. It prints a1.i is equal to 2, a1.f is equal to 4.7. a2.i is equal to 2, a2.f is equal to 4.7, a1.i is equal to 5. Here the values has been changed. So a1.i is equal to 5, a1.f is equal to 3.2, a2.i is equal to 2 and a2.f is equal to 4.7. So that's how for a given class the bytecode and other class level data gets loaded into the method area when you create instance of that class for the first time. And this activity occurs only once. Now onwards we consider only two memory areas of JVM in animation, the heap and the stack. I will show the method area again when it is necessary. For now just assume that the method area is there and containing bytecode and other class level data of various classes. This is another example. Here we will slightly discuss about hash code of an object and garbage object. Similar to previous case, the bytecode of the class main starts execution and various memory areas gets created. Here we have shown only heap and stack memory areas. The execution starts from the method main and a stack frame of the method main gets created, having location for the variable args of type string array. The location for the variable args contains an address. We will discuss about this address in the later session. Then after similar to previous examples, we have created a new object of class add and store the reference of that object into the reference variable a1 in the stack frame of method main. Then after we create another object of class add and we store address of that object into the reference variable a2. In the next line we are printing the instance variables corresponding to the object whose address is stored into the reference variable a1. It will print the values of the instance variables whose address is stored into the reference variable a1. And it prints a1.i is equal to 2 and a1.f is equal to 4.7. Then after we are printing values of the instance variables I and f of an object whose address is stored into the reference variable a2. Since the reference variable a2 contains the address of this object, so this statement prints a2.i is equal to 2 and a2.f is equal to 4.7. And then we are printing values of a1 and a2. Note here that here we are not printing the instance variable corresponding to an object whose address is stored in a1 or a2. Here directly we are trying to print variables a1 and a2. So what will happen if we print the reference variables a1 and a2 directly? When you try to print the reference variables directly, then it prints the hash code. It prints a1 is equal to hash code of a1. It prints a1 is equal to hash code of a1. And then it prints a2 is equal to hash code of a2. It prints a2 is equal to hash code of a2. What is hash code and how it looks like? We will see deeply about the hash code of an object in the later sessions. For now, you consider the hash code as a unique identity of an object. So these values are called hash code of the objects. Hash code is the unique identity of an object. For two different objects of the same class, the value of the hash code will be different. Then after we have this statement, a1 is equal to a2. When this statement executes, whatever is stored in a2 gets stored into the a1. So value of the variable a2 now is stored into the value of the variable a1. Now both the reference variables a1 and a2 having address of same object. Now the stack frame of the method main loses the address of this object, and there is no way that the stack frame of the method main again gain the address of this object. It's just like initially you hold a gas balloon and then you left it. After that you cannot get it again. So the stack frame of the main cannot get the address of this object again. because the Java does not allow programmers to use addresses. Now this object is of no use because we cannot have address of this object, so we cannot use it ever. That's how this object becomes a garbage. The object as addr1 is now a garbage. This object is of no use and just wasting the heap memory. But you do not have to worry about such objects which loses its connection with the stack. JVM take care of such objects and remove these types of objects from the heap automatically. Then after we are trying to print the values of the instance variables of an object whose address is stored into the reference variable a1. In this case, the reference variable a1 contains the address of this object. So it prints a1.I is equal to 2 and a1.f is equal to 4.7. In the next line, we need to print values of the instance variables I and f of an object whose address is stored into the reference variable a2. The reference variable a2 contains the address of this object. So this line prints a2.I is equal to 2 and a2.f is equal to 4.7. So even if these two lines using the different reference variables, but they are printing the instance variables of the same object. After that, we are trying to print the reference variables itself. We know that the printing only reference variables prints the hash code of the given objects. But since here both reference variables containing the address of the same object, so the hash codes will be printed are same. You can see here both reference variables a1 and a2 have same hash codes because they are pointing to same object. Let me execute this code practically. Open calc.java and this is the code. We are printing the hash codes of a1 and a2, and finally after assigning the reference of same objects in the both variables a1 and a2, we are again printing the hash code of a1 and a2. Let me save and execute this code. Java C calc.java. Compiles fine, then run it java main since the class main contains the method main. It executes fine. You can see here the reference variables a1 and a2 contains the address of different objects. But in this case, both reference variables a1 and a2 contains the address of same object. So here hash codes are different, but here hash codes are same. The object whose reference was initially assigned to the variable a2 now got assigned to both a1 and a2. So you can see here in this line, both a1 and a2 contains a hash code and similar hash code is contained by a2 in this line. If you do not use the new operator to create a new object, then like other primitive local variables, the local variable a1 is also said to be uninitialized and compiler will throw an error. Here we are using the variable a1, so at this line the compiler throws an error. But if you are coming from the C++ world, the C++ world is little different. In C++, writing add a1 creates an object in the stack area like primitive variable. In the case of C++, if you write this line, the variable a1 itself becomes an object. But in the case of Java, this statement creates only a reference variable of a1. It does not create an object. In Java, object always gets created in the heap area using new operator. Here a1 is the reference to the object. Unlike C++, in Java you cannot create an object in the stack area like primitive variables. Let me try this code practically. Open calc.java and write here add a1 and then semicolon. Now in this line we are using the variable a1 without initializing it. That's how the compiler will throw an error. Let me save and compile it. Java C calc.java. The compiler throws an error in the line number 12. Variable a1 might not have been initialized. Here we are using the variable a1 which might not have been initialized. Here in this statement we are assigning the value null to the variable of type add. So in this case the variable a1 is initialized, but the variable a1 does not contain address of any other object, but the variable a1 contains null. In this line you are trying to use the variable a1 whose value is null, and you are trying to print the instance variable I of an object whose address is stored into the reference variable a1. But the reference variable a1 does not contain address of any object, but it contains null. Even if the reference variable a1 is initialized, but it contains null, it does not contain address of any other object. So if you try to do like this, then the compiler will compile it silently. It will not throw any error. But at the runtime, the JVM will throw an exception, the null pointer exception. Let me try this code practically. Open calc.java and this is the code. Here we have assigned the value null into the reference variable of type add. Let me save and execute this code. Java C calc.java. It compiles fine, then run it Java main because the class main contains the method main. Press enter. JVM says exception in thread main java.lang.NullPointerException. And this exception occurs at the line number 12 of the calc.java in the method main of the class main. But here you can see the scenario is little different. Initially we have the value null in the reference variable a1 of type add. Then after we have created an object whose reference is stored in the variable a2. In these 3 lines we are not using the instance variable corresponding to the reference variable a1. So these 3 lines will not throw any error. a2.i will print the instance variable corresponding to an object whose reference is stored in the reference variable a2. Similarly, a2.f prints the instance variable f of an object whose address is stored into the reference variable a2. Since a2 contains the address of an object, so this line does not throw any error. In this line we are printing the hash code of the object whose reference is stored into the variable a2. And in this line we are printing the variable a1. Printing the variable a1 is supposed to print the hash code of an object whose address is stored into the reference variable a1. But in this case the reference variable a1 contains null. That's how printing only the variable a1 will print null. If there was address of an object stored into the reference variable a1, then it could print a hash code. But here since the reference variable a1 contains the value null, that's how this statement will print a1 is equal to null. Then after we are assigning whatever is stored into the reference variable a2 in the reference variable a1. So now the reference variable a1 contains the address of an object whose address is also stored into the reference variable a2. That's how the printing a1.i and printing a1.f prints the instance variables of an object whose address is stored into the reference variable a2, because the same address is stored into the reference variable a1 also. Then after in this line we are printing a2.i and a2.f, which prints the instance variables of an object whose address is stored into the reference variable a2. After that we are printing the reference variable a2 itself. Printing the reference variable of an a2 prints the hash code of an object whose address is stored into the reference variable a2. Now since the address of same object which is stored into the reference variable a2 is also stored into the reference variable a1. That's how printing the reference variable a1 prints the same hash code which has been printed by a2. So you can see that these two hash codes are same. This is a task for you to execute this code in a Java program. One more point I want to discuss, you can create an object without storing its reference to any reference variable. Here you can see we are creating an object without storing its reference in any reference variable. Here we are printing value of a1 which will print null. Here we are printing the reference variable a2 which will print hash code of the created object here. And here we will print hash code of the newly created object. In fact, here we are creating the third object. The first object has been created here whose reference is stored into the reference variable a2. The second object has been created here. For this object we are not storing its reference in any reference variable. That's how just after creation the object becomes a garbage. Here we are creating the third object and the reference of this third object also not getting stored into the any reference variable. That's how the third object created here becomes a garbage just after creation. Let me save and compile this code. Java C, calc.java, compiles fine, then run it, Java main. It runs fine and printing a1 is equal to null, a2 is equal to hash code of an object whose reference is stored into the variable a2. And here we are printing the hash code of an object whose address is not stored into the any reference variable. We are just created this object into the system.out.println statement. That's all for this video guys. Don't forget to like and share this video, subscribe this channel if you are new, and leave your valuable comments in the comment section below. Thanks for watching. See you in the next video.